Hey, welcome. This is the web app track. This is Stefan Esser talking about utilizing code reuse and return-oriented programming in PHP application exploits.
Okay. Hello. Welcome to utilizing code reuse and return-oriented programming in PHP application exploits. I will skip my introduction, so I just want to tell you what the talk is about. Today I want to speak about something like return-oriented programming for PHP applications. So I want to take return-oriented programming to the PHP level. This will be the first part of the presentation, and the second part of the presentation will be I will demonstrate a vulnerability in PHP that can be exploited with traditional return-oriented programming methods. So during the last day, there were already several presentations about return-oriented programming or return-oriented programming style topics. So I just will give a short introduction what return-oriented programming is all about. So the basic idea of return-oriented programming is that you, instead of injecting your shellcode into an application, you will inject some kind of data that redirects the application's code flow. And the idea is to not inject code, but to use the already existing code. And the general idea is that when you have pieces of already existing code in an application, you can rearrange them in a way that they will be useful for you as an attacker. At least you hope so. But when the application is big enough, you usually will find something. So in the past, people always analyzed return-oriented programming and code reuse topic on consumer architectures like x86, AMD, 64, SPARC, PowerPC, the ARM architecture because of all the mobile devices. And when you saw the talk yesterday, Dynamics guys are applying return-oriented programming to their reverse engineering intermediate language, which is called Rail. And last year there was also a paper about people using return-oriented programming against selection or voting systems. But so far there is no real research on return-oriented programming or code reuse for PHP or web applications. So when you look at code reuse techniques, you can classify them, and usually code reuse is like the topic, the major theme. And when you look at it, return-oriented programming is just a subset of code reuse techniques. And when you look at this, a subset of return-oriented programming is return to libc. And on the other side, there's something most people don't speak about, but code reuse is usually bigger. So I put in the big question mark for now. So when you look at return-oriented programming on the low-level side of maybe x86, you see that all these techniques, return-oriented programming and return to libc, based on the fact that you somehow hijack the call stack of the application. And you usually try to manipulate the call stack in a way that the return instructions that are present in the application will return to code you want it to execute. And the code you will usually execute is most of the time some useful instructions for you and then followed by the return. And in order to do this, you need full control over the stack. The example just shows one of the possible stack frames that could be used for return-oriented programming. In this case, it's some kind of system call that is executed, and yeah. So when you apply these techniques directly to PHP, you will realize that that's not possible in PHP. The reason for that is there's not a single call stack that you could overwrite. The PHP application call stack is actually on 3 levels. A part of it is stored in the real stack, in the program stack. A part of it is in allocated heap structures that is most probably randomized on modern systems. And also the data segment contains pointers that are used by the executor to change the execution. So a traditional return-oriented programming attack is not possible because you usually can only override one piece of memory, but you cannot override 3 or 4 at the same time, especially if you don't know the addresses. So the other thing is, when you want to return to PHP bytecode, for example, PHP bytecode is always allocated on the heap, so it will be in completely random positions on modern Linux systems. So return-oriented programming seems impossible for PHP. But if you remember this picture, there's a big question mark on the side, and we want to fill this big question mark with a new technique, which I call property-oriented programming. Short is POP. So what is property-oriented programming? The idea is that instead of overwriting some call stack or manipulating a call stack, you try to exchange the objects used in an application. So normally when you have objects, they have properties, and these objects call other methods of other objects stored in their properties. And now the idea is that I replace the objects stored in the properties, and so I can redirect the code flow. This graphic shows like the circles are just random objects, and you see one object is calling the other in the method of another object, and so on. And basically, if I can override the objects or the properties of the objects, I can choose which object is executed next. The only thing that's maybe static is which method is called. Okay, when you go down to the x86 level, this is not that easy, but this is just a general concept, and in PHP it works like this. So just believe me, like now. So when you look at PHP, the problem is this technique has some limitations, because in x86 and return-oriented programming usually can jump anywhere in the binary. But in PHP you cannot jump anywhere in the binary, you can only jump to starts of methods. So this is a limitation in comparison to other exploits. The other thing is, you usually cannot just override some objects in memory, because the objects in memory are in random positions, and yeah, so that's not the way to go normally. So what you need usually is a way to create objects from remote and to fill their properties. And in PHP that's usually done by the unserialized function. I will go on that now. So unserialized is a function of PHP that is used to deserialize previously serialized data. It supports nearly all of PHP's data types. The only data type that's not supported is resources, but all the normal things like integers, floating points, booleans, arrays, strings, objects, and even references can be serialized and unserialized. And when you look at PHP applications, you will see that they are often expose this function to user input. And when you look at the history of the function, you see that there are a lot of vulnerabilities in the parser, in the unserialized parser itself in the history. So what we want to do is like create arbitrary objects. So the good thing of unserialized is it allows us to create objects and to fill all their properties. The problem you usually have when you have vulnerability that allows you to create an object is that you can only override the public properties. But with unserialized, you can override each property, the public, the private, or the protected ones. But don't mistake that for like a full unserialized of objects. You can only unserialize the instance of a class that already exists. So you cannot just inject a new method that you with bytecode or so. You cannot just inject code that gets executed. That's not possible. However, whenever you unserialize an object, PHP will check if this object has a wake-up method in its class definition. If it has a wake-up method, it will execute it. And the other thing that's new in PHP 5, although PHP 5 is already old, but in PHP 5 the whole object model was restructured, and so now objects have real destructors. So the thing is, when you unserialize an object and it gets later destroyed, the destructor will be called. In PHP 4, nothing like this happened. So this means when you unserialize an object that's existing in application, there are two possibilities where directly code will be executed. Either it's a wake-up method or the destructor will be executed if there is one. So, to show you the internal working of unserialized, I have a little example. One thing that's very important for the second part of the presentation is on the right side you see a variable table. This is an internal table of unserialized that keeps track of all the variables created by the unserialized parser during the single call of unserialized. The idea of that is when you want to unserialize a reference, you need to know which variable you want to reference to. So what happens is that unserialized creates a variable table where every variable it creates is inserted, or a pointer to the variable is inserted. And later when you create a reference to the third slot, then unserialized will look into the variable table and get the variable from there. So this example starts with unserializing in an array. This array is supposed to have 6 elements, and so you see PHP creates an array with 6 elements. Then it continues and creates all the content of the array. The first thing is the key is a 0, an integer 0, and the value is an integer 0. So it will insert it in the first slot of the array, and you see that the variable table is already filling with the array and a pointer to the first entry. And this continues to a floating point 2.0, a string ABCD, and now we get a reference. And now it's a reference to the third slot. So PHP will go to the third slot and see, oh, it's a pointer to the floating point 2.0, so this will be the reference to the 2.0. And the next element should be like any class. I call it my class in this time. It could be any class. And you can see that this has 2 properties, A and B. And PHP will now continue to unserialize each property, which again will be a reference to the class itself and a null value. Again, you see every time a variable is created, it's inserted in the variable table. And now we have unserialized the whole object, and what happens now is PHP will attempt to execute the wake up. If there's a wake up, it will be executed, otherwise it will just continue unserializing the rest. In this case, it will create an internal PHP object of type SPL object storage. We'll go to this later. And yeah, after that it will be finished. Okay, that's how unserialized works. And I already told you that putting user input in unserialized is maybe not a good idea. So what actually is required for an application to be vulnerable so that we can do a property-oriented programming attack? Of course, the most obvious way that an application can be vulnerable to this is if it puts user input directly into unserialized. But when you look at PHP applications, you will see that unserialized is used in very many different places, and not always it's user input that is put into unserialized. And when you look at all the different types of web application vulnerabilities, you will see that there are other kind of vulnerability classes that can be leveraged to attack unserialized. So I will go through each of the classes now. So the first one is what I repeated several times now. You just unserialize user input directly. Why would you do that? PHP application developers are usually lazy, and it's the easiest way to transfer bigger amounts of data between, for example, the client and the server. So every time a PHP application has to transfer a whole array to the client and back, the PHP application developer has to choose a way to do that. And traditionally, they were all lazy and just used serialized and unserialized. So they put the array to serialize and just use the string, for example, for a hidden form field. And this is the most of the time you see unserialized and serialized content in hidden HTML form fields or in the cookie. Actually, this is an example from TikiWiki. And TikiWiki is even more nice. It's just unserialized 2 request variables, which is a collection of pages that is supposed to be printed. And it will do some modification of this data. And later, the modified data is serialized again and given back to the user. This is very good for an attack, and you see later why. So why do people do that? The reason for that is PHP code is usually very old, and they all learned programming in PHP 4 days. And in PHP 4, it was not so dangerous to use unserialized because there were no destructors, so there was no unintended code execution. And wake up methods were very, very, very seldom, and you have to program on your own. So usually no one used wake up, so there was no danger at all, except for vulnerabilities in the unserialized parser, and we had a lot of them in the past. So the next thing you would see in modern PHP applications is that they always use some kind of caching, because they're usually too slow, so they cache a lot in memory, in the database, or in files. And of course, files are still the most often used thing to store big data arrays. So you will see that a lot of PHP applications store serialized data in files. What does this mean? This means, first of all, when the application is able to store serialized data in files, this means there must be some directory on the web server that is writable, because otherwise it cannot be cached. It's not necessary that this is inside the document root. This can be anywhere on the server, maybe the temp directory and subdirectory of the temp directory, but there must be a single directory that's writable. So this also means when there's a file upload vulnerability in the application, there must be a single directory that's maybe writable for the file upload. And normally when you can like upload something in a temporary directory, and the temporary directory is not accessible, that's usually not a problem for an application. So it's a file upload vulnerability maybe, but it's not ranked so high in severity because you cannot do anything with it. But when you take the caching files into considerations, now when you can upload a file to this temporary directory, you can upload maybe a cache file that is used later and unserialized. So you can attack unserialized again. So the next part where you see unserialized and serialized very often is when you look at the web application programming interface, the web API. Many PHP-style web applications will provide a serialized and unserialized way to maybe talk REST. They don't use JSON, they use serialized and unserialized. The most popular application like this is WordPress. So when you have a WordPress blog, it will talk from time to time with api.wordpress.org in PHP serialized and unserialized form. And the problem here is it's talking HTTP, so any kind of HTTP man-in-the-middle attack can inject malicious serialized data into your unserialized on your blog. Actually, this example is really taken from WordPress. So you see it will send some requests to the WordPress API and check if there's a new version of a plugin, and then we'll unserialize the code. And and if WordPress would have interesting objects, this will be a remote code execution vulnerability. But luckily there's no such object. So only if you have a vulnerability in the parser you can maybe attack WordPress. The next thing where you find unserialized is with databases. There are a lot of PHP applications that store settings or sessions in a serialized form in the database. This means if you have a SQL injection vulnerability in a PHP application, you maybe can modify the field that is serialized. With older PHP applications this was very tricky because you cannot stack queries with MySQL in early PHP versions. But nowadays, especially all these Zen framework applications, they use PDO MySQL to access the MySQL database. And PDO MySQL has no protection against stacked queries. So when you have an application with PDO MySQL, you can inject the usual semicolon drop tables. and this was not possible previously. But now you can do that with modern applications, and so you can modify all the database. Okay, when you can modify all the database, maybe you can do other interesting things, but you can still attack unserialize. Actually, I did an audit for our sister company, Mayflower, who develops a PH project. I did this in February, I think, and they have unserialize of database content, and they also had a SQL injection, so I was able to unserialize something and execute arbitrary code. The last thing I want to get into is a vulnerability I disclosed during the month of PHP security in May. It was actually the last one on the last day. And the thing is that there's a problem in the session deserializer. And the problem is whenever a session key starts with an exclamation mark, this deserializer gets confused. And so if you have an application that allows you to put arbitrary keys into a session, or to have a prefix, arbitrary prefix for session variables, which sometimes happens. You see some examples down there. When something like this exists in your application, then you can more or less inject exclamation mark keys with arbitrary values. And now the problem is when this gets deserialized during the session load, it will confuse the deserializer, and suddenly you can inject arbitrary serialized data into the session. Okay, if the application allows to put anything in the session, then you can put anything in, but these are always strings. But due to this vulnerability, you can put anything serialized in there. So you can attack unserialized, or you can just create arbitrary objects anyway in the session, maybe a valid user object. Normally you can just inject a string, but with this vulnerability you can inject an arbitrary user object if your application has something like this. So these were the vulnerability classes that could allow attacks against unserialized, but to do property-oriented programming, you need more. You need, first of all, you need this deserializing of malicious input, but you also need classes that are usable for your POP chain, your property-oriented programming chain. And a class is usable for the POP chain if it can start the POP chain. Okay, first of all, the class must be available in the application and at the time of the unserialize. Then you need something to start the POP chain. You need something to transfer the control from one object to the other. And in the end, you need some object with interesting operations. I will go on this later. So, first of all, class availability. When an application unserializes something and it creates objects, then you can only create the objects that PHP knows about at this moment. So this means if you unserialize an object called X, A, B, C, D, then PHP will check if this object is available, if this class is available, and if it's not available, it will create a so-called incomplete class, which is nothing more like a dummy object with properties. So this is not usable. So basically this means you can only use classes for your attack that are already included at the moment of the unserialize. This limits very much the amount of classes you can use for the attack. On the other hand, modern PHP applications have the possibility to register a so-called autoload function, which is a class autoloader. So in the case PHP doesn't find the object, it will first call the autoloader, and the autoloader can check if it knows the class or knows how to load the class or create the class. So in modern application, you sometimes are able to instance every single object of the application because the autoloader will just load the right object at the right time. So I already said you are really limited in how your POP chain will look like and what methods you can use. So the problem in PHP is you have to find a way to start the chain at all. So And this means your unserialized must somehow, or the code afterwards must somehow trigger execution of the objects you just created. And I already mentioned there's wake up and there's destruct. These are most obvious ways to start a pop chain. But there are some other magic methods in PHP that might allow you to start a pop chain also. This is toString. So every time you have an object and it gets concatenated to a string, it will call the toString. So maybe you find a usable toString method. When a method is called on an object and the method is not known, then it will try to find the call magic method. If it exists, then it will execute that. And get and set are for magic properties, so the getter and setter. In real world, so far, I only started pop chains with wake up and destruct. So the others are theoretically possible, but so far I haven't found an application that is vulnerable to this. And the example just shows you have a class, I call it PopStarter, and it has a destructor. So when you unserialize this class and it will get destroyed, the destruct will be executed. In this case, there's nothing in there, so nothing would be happening. So the next thing you always need in a pop chain is a way to transfer control from one object to another, to the method of another. Because you usually will not find a destructor that does something very interesting for you. In the past, you could find destructors that were deleting files, so you could delete a file immediately. Or you find something that writes a log file, so you could write a file to the disk. But most of the time, the destructor will do nothing else than call like another method of another object. So you need a way to transfer the control from one object to the other. The most obvious thing is that you have a property that gets dereferenced and the method of this new object is executed. You see this in the example. The property 2 is used as object and the method B is executed on the property, on the other object. Another way would be that property 3 is also an object and the data property is assigned some value. So you maybe can hit a magic setter in another object. And the third thing is a property is appended to a string, so you could hit a toString method of another object. So this always transfers execution from one object to the other. And usually you want to chain many of them until you reach a method that is usable for you. And these are the end of pop chains are usually classes with interesting methods. This means an interesting operation is, you can see this, file access, database access, access to the session, to access to the mail function. Sometimes you even get the execution of PHP code or inclusion of PHP code. And in this example, this would allow to load an arbitrary file in memory, mail it to any email address, and in the end attempt to delete the file. So if you find this somewhere in the application, you can completely control what it does because you have control of all the properties, and all the properties are required to do what you want. So you can choose any file because you can set the temp file property. You can choose the to of the email, the subject of the email, and yeah, most of the times files you want to steal are not writable anyway, so the unlink will just error. And you see this is implemented in the method B, so you would have to combine it with the previously found code flow transfer object that called the method B of property 2. And because you also have control about property 2, you can just tell property 2 to be an object of type operation. So to make this more clear, I will give an example. The example is pvik. Pvik is a very popular open source user tracking system. It's supposed to be very similar to Google Analytics. And I don't know about America, but in Germany it's used in many places. And all the major German political parties have installed it on their website. All the smaller banks have it installed on their website because all the smaller banks are powered by two companies, and these two companies both use Piwik. So this renders all the banks vulnerable. You will find, ironically, security companies that use Piwik, like the German Safer Shopping, which is supposed to be a certificate for shops to be secure, which usually is not, they are not. And also many popular open source projects have it on their website. For example, Typo3, which is the, at least in Germany, the most prominent content management system. And in the past, kde.org and so on, they all had Piwik. And a vulnerability that was unserializing user input and especially the cookie and allowed remote code execution was disclosed by me in December 2009. And now we will look at this vulnerability. And the first thing is, when you look at it now, 7 months later, you will maybe think, oh, it's old news, it's fixed. But the problem here is PHP developers always know things better. So my recommendation to remove the unserialized was ignored, how to fix it. And so what they did is they used unserialized still and just put in a blacklist. And we all know that blacklists are the most effective way to ensure security. And after looking at it again and again, and looking at the unserialized part in detail, it was very obvious that the blacklist is ineffective. So I won't tell you how it works correctly, but if you prepare the serialized string in a special way, you can bypass all their blacklists. This means the vulnerability I disclosed 7 months ago is still exploitable. It's not yet fixed, so I will not give you the details how to manipulate. But if you can read source code and can compare pathers to blacklists, you maybe find out how to exploit it. So when you want to exploit Piwik, you need, as always, a start of a pop chain. So what you do is you take the source code, take your favorite text editor or IDE, and you will just search for wake up and destruct. And when you do that with Piwik, you see that there are 8 classes from the Zen framework, because Piwik comes with a small subset of the Zen framework. 8 classes of the Zen framework come with wake up, 11 classes come with destruct, and 11 classes from the Piwik core classes also come with destruct. So what you would do now is you would go through all the classes and check the method in detail and check what they do. I can tell you with the wake-ups, you will most of the time will see that they're either empty, unsetting some properties, calling their parents wake-up, or doing something else that is not so interesting. So we can skip wake-up most of the time. The destructors, on the other hand, do more complex things. But the thing is, I will only go into the Zen framework one this time. In December, I showed that the Piwik core comes with a config object, and this config object can directly be used to write arbitrary files to the hard disk. But I will use the more complicated way now. So I did a lot of research in Zen framework last year, so I already know which of the classes are usable for pop chains. So I will just tell you which one. My most the most usable one is a send log. You see, the destructor is not doing very much. The destructor just goes through all the writer's properties, and for each writer property, it will call the shutdown method. So no interesting operation, just transfer of control from one object to the other. Of course, because you unserialize this, you have full control of the writers, so you can put any object in there that you want. So the next thing you want to do is you need to scan the source code again for something that has a shutdown method. Luckily, this time you only have 6 hits inside the Zen framework, and only one of them is interesting. The others are just doing completely useless things like closing a file or that was not open previously, or delete some property. So the only interesting one is the send log writer mail. And this is actually a very complicated method. What it does is it basically checks if it has events to mail. And if it has events to mail, then it will call the mail class usually and create the text section of the email, and later create the HTML section of the email. And what you don't see here, after that it will mail the mail. So what you can do here is actually you can spam anyone with any text you want, serializing and using these two classes I just showed you. If you just combine these two classes, you can send emails. But we want to have more. We want to have more control. We want to have code execution, so we continue. So what we have to do now is we have to find, for each of the properties that is usable, which is mail and layout in this case, we have to put in fitting objects. For the mail property, it's very simple because there's only the send mail class that will fit. So you just put it in there. On the other hand, there's the render method of the layout property, and the render method is in many classes of Pivik. So in 14 classes of Pivik's core, in 6 classes of the HTML peer library, and in 21 classes of the Send framework, and even in 1 Pivik plugin. So you have to log through a lot of classes. And I don't want to do that because we don't have the time. So I'll just tell you Pivik view is the most interesting one. Pivik view is actually, the render method is a large piece of code, and most of it is wrapped in try-catch blocks. So actually you can ignore nearly everything of this. And only the last line is very interesting because it uses the property smarty and calls the fetch method. And you also see that the parameter to the fetch method is the template property, so you control both. And obviously, when it's already called smarty, then it's supposed to be a smarty object. And we go through this now faster. And it's really a smarty object you want to have in there. Because when you know smarty, you will know that smarty allows you to have templates that execute code and so on. So when you look at the fetch method, you will see that there's a lot of code, and at some point it will check if the resource is already compiled or is already in the cache. So it will call the isCompiled method, and you see down there it will call the fetch resource info, and fetch resource info will pass the resource name that you gave it with your property. And and what you see here is that the pass resource name will split the resource name you give it and split it into a resource type and a resource name. And then for every resource type that is defined, it's possible to define a callback that gets called on the name. And because we have complete control of the properties of the smarty object, we can just put in an arbitrary resource we call XPL for exploit, and we say that the callback is this, which is the smarty class, and the evil property method. So actually, when it splits the resource name, it will take the XPL as type, and everything after that will be what it will pass to this callback. So we can execute arbitrary PHP code. And now you just need to set this together, and when you serialize that, you will get something like this down below. And when you unserialize this from within Pivik, it will execute the PHP info function in this case. But by just changing what kind of code you want to execute, you can change it to whatever you like. You see in the Pivik view, there's a template, a property, and you just said it's XPL for the XPL resource you just injected, double point, and then the code you want to execute. And you can put anything you want in there. So, okay, this is Pivik. The problem is, I told you, like, there's some applications that unserialize user input, like WordPress, but they don't have interesting objects. So they have no destructors, no wake-ups, and so you cannot exploit them with the property-oriented programming way. You need another way. And what you need is a vulnerability in the unserialized part itself. And what I show you is a use of the free vulnerability in the SPL object storage class of PHP. And this is actually was 0 day until like 1 month ago, and 1 week ago it was fixed. So it will not work on most on the new PHP version, but no one is using the latest PHP version anyway. So the idea of the bug is that SPL object storage is an object map. So you can put objects into there and map some extra data to it. So for example, you can put 1, 2, 3 as extra data for the alpha object, and you put 4, 5, 6 for the beta object as extra data. But what you can also do is put 2 different kinds of data for the same object. So this means you first put in 1, 2, 3, and then 4, 5, 6 for the same object. What will happen is that SPL object storage will delete the old value, in this case 1, 2, 3. So why could this be a problem? A problem is because you can also inject this inside unserialize. So you can use unserialize to unserialize some SPL object storage thing and use the same object as key 2 times. You can do that by using references, or because the actual type of the variable was not checked in previous PHP version, you could use the same integer 2 times. What will happen is that in PHP 5.3, the extra data that was previously at the same key will be deleted. So this is not a problem at all, but the deletion is done inside the SPL object storage. So unserialized doesn't know about it. And unserialized, you remember there was this variable table that's used for references, and so unserialized has still a pointer to this variable that was just freed. So when you now continues to unserialize and use a reference to the extra data that was already freed, it's perfectly possible because unserialized doesn't know that this variable doesn't exist anymore. So you can put in references to already deleted objects or classes or whatever, arrays or strings or anything. And now I will show you how you can use this for info leaks and code execution. First of all, I remember you of TikiWiki. You can have code execution if the application unserializes. But if you want like a really good exploit, you need that the application unserializes it, modifies it, serializes it again, and gives it back to you. This works in this case in TikiWiki. This would also work in pvik, or the old version of pvik that is not exploitable with property-oriented programming, but through this bug. And it should also be possible with OpenX, the most prominent ad software. So we will do leak after free attacks. The basic idea of leak after free attacks is that you give the application some serialized data, it will unserialize it, and the unserialization will trigger the exploit, the bug somehow. And what you want to do is you want to create some variables in unserialize and then free them. So there are a lot of pointers in the var table that point to non-existing variables, and all these variables are put to the memory cache, the free memory cache. The next thing you want to do in the unserialize is to create a string variable of the same length as the internal data structure used by PHP to keep track of variables, which is called setValue. And if you create a string inside the unserialized that looks like a fake setval, it's theoretically possible to use it. And because of the memory cache, it will be allocated in the same spot as the previously freed variable. And what you can do now is you can use the reference in the unserialized to create a reference to the already freed variable. And because instead of the variable there's now your string, you have full control about the variable that is created inside of PHP. Because you actually have you can change the binary representation of the variable in memory. Yeah, so all leak after free attacks will work like this, and in the end we just read the serialized result back, and yeah. So what we want to do first is we want to leak arbitrary places in memory, and we can do that with the kind of attack. What we do is we create a fake string variable inside PHP. A string variable inside PHP consists of the string pointer, followed by the string length, followed by a reference counter, followed by the byte 6, which says this is a string, and then followed by a byte of 0, which says this is not a copy on write variable. So what we have here is we have told PHP that there's obviously a string variable in memory starting at B7342118, which is a pointer, a 32-bit pointer. And PHP will believe that if it sees this variable and the reference to this variable. And when it modifies now the unserialized data and gives you the serialized form back, it will go to the string and see, oh yeah, I have to take the 1024 bytes from this piece of memory and give it back to him. So to actually achieve the attack, you just have to send this little piece of serialized data. What it does is, first it creates an array of integers. Then it frees the integers. It frees the arrays, and this frees all the integers. This means you have a lot of free variables right now, and a lot of references in the var table that are pointing to not allocated memory. And now you put up your fake set val, and because of the memory cache, it will be allocated in the same spot of one of the previously integer variables. And when you then create a reference to the right variable, to the right slot of the freed variables, then you suddenly have full PHP that there's a string in memory at the data you supplied. And when you send this to TikiWiki, TikiWiki will give you something serialized back, and this will look like this. You see that there's a lot of garbage, but actually this is the memory content, and this, I think that was the code segment. It was, it was a code segment of PHP in this case. And of course, this is just garbage. You usually get the real thing, so you have the real bytes. And you just have leaked 1024 bytes of the memory. The problem here is, of course, when you put in this pointer I just showed you, most probably your system will crash because your PHP will not be at the same place. So you need a way to start where to look for. And this can be done with a more complicated way. Again, you create a fake string. But this time you put in any pointer you want, you don't care. In this case it's 41414141. And you will do more or less the same attack. It's just a little bit more complicated. The idea now is you have first to create an array of integers just to allocate something, to make the memory cache empty. Then you again create an array of integers that you free immediately again. So you have all these empty spots in the variable table. And then you create an array that contains your fake string and the empty object in alternating sequence. And then you freeze it again. And this is very important. You freeze it again. And then you create the reference to already freed thing. The idea here is the moment you free the fake integer, the fake string, the first 4 bytes will be overwritten by the memory cache with a pointer to the previously freed memory. So you have just created a string variable that points into a heap. because you have just let the memory cache fill out the pointer that you wanted for you. Yeah, aside from that, the attack is the same. When you send this to TikiWiki, you get something back. And this time, you will take this memory and scan for it. You will scan for objects in there, because you had all the objects in memory. What you will search for is like 4 times 0, followed by 5, followed by 0, because this is the pattern that will help you to find empty, already freed objects, because the reference count is 0, so, and it's an object. So when you find this in memory, you assume that the 4 bytes before are pointed to the object handlers. And the object handlers is a table, usually in the data segment, especially for PHP. Internal object is always in the PHP data segment. And yeah, so by just going through the memory just leaked, you can find out where the data segment of PHP is, at least the one struct that you are interested in now. And with the previous year attack that allows you to leak anything, you can just grab the memory at this place, read in the handler table, and in the handler table you have a lot of pointers in the code segment of PHP. So what you have now is you know where some places of PHP are in memory, the code segment and the data segment. The code segment is more interesting, because once you have the code segment, a pointer inside the code segment of PHP, you can just go backward page by page until you hit the executable header. In case of Linux, it will be an ELF header. In Windows, it will be a portable executable header. But for now, we concentrate on Linux, so it will be an ELF header. And you can just read the header, because you can leak anything. So you can leak all the structures inside the ELF header, and you can actually steal the whole binary remotely. You can just grab every piece of the binary and get it through TikiWiki on your server. And of course, when you have a binary, you can look up all the symbols in memory. You know which function of PHP is. And you can also go through other modules. For example, PHP is linked to the Apache modules, so you can find the Apache core. And with the Apache core, you can find the other loaded Apache modules, for example, mod SSL, and from there you can steal the private SSL key from memory. But you can also use this information to create a code execution exploit. I will show you that now. So the idea is, to do the code execution exploit is you first need to know the location of the stack, because stack is usually completely randomized, even more than all the other things, so it's really hard to find the stack. But you can already look up any symbol in PHP, so what you do is you look up the executor globals. And the executor globals is like I think it's the biggest, no, second biggest struct inside of PHP. And one of these entries is the jump buff. The jump buff is the data used by setJump and longjump, and PHP uses this for emulation of try-catch at the C level. And what you can do is you can find the jump off pointer, and this jump off pointer is stored on a stack. So if you find the jump off pointer, you have an address in the stack. And of course, from there you can leak up and down as much as you want. Okay, until you hit like a page that is not allocated. The second thing is you want to have control of the stack, because you want to put some data structure on the stack that you can use for your attack. And PHP is actually very simple to get control of some piece of the stack, because you can send in a special type of post request, which is the RFC 1867 multipart form data, which is used for file uploads. And when you do an upload like this, the parser will use some stack buffers, and the stack buffers are very big, and they're in a way on the stack that the functions coming afterwards will not completely overwrite them, because the function afterwards will also have big stack buffers, so there is always a big slot that is never overwritten. So if you can find that and put arbitrary data there, you have injected arbitrary data to a known location in the stack. So what you do is you put in like a post request with a special layout and put in your pattern, and then you search just the pattern in your via the leaking, and then you know the address of this stack buffer. And because in the PHP module it's all forked from Apache in the non-thread way, the stack will always be in the same place. So what you do now, what you do have now is you have a known location on the stack that contains your data. And what you want to do now is you want to create a fake object. You saw how we created fake string. Fake objects are more or less the same. And once you have created the fake object, you want to destroy it. The reason for that is when a variable is destroyed, it was called the setval detour func in the end. And in case of objects, it will go to the object handler table and use the second handler, the delref handler, and will delete it. When you look at the assembly, you will see that when this is called, the ESI register is actually pointing to your fake object, and the EAX register is pointing to the handler table. So this is the table in stack that you control. So the idea of the exploit is very simple. You have an object handler table, which is actually your data on the stack, and the second entry is your delref handler, and you will put the delref handler to an exchange EAX ASP followed by a ret. You can search that by leaking the code segment of PHP remotely, so you can find it in memory. And because the handler table is pointed to by EAX, the exchange EAX ESP will change the stack pointer into your buffer. And from there you can just do the normal return-oriented programming. So this will look like this. You have a fake variable. In this case, it's an object. An object is identified by the 5, not the 6, but a 5. You put in a reference counter of -1, so that it will be freed. You put in the object handler's pointer will be a pointer to the stack location you just leaked and controlled. And the object handler can be anything. And what you do now is actually you do the same attack. Just this time you don't put in a string, a fake string. You use the same code just to put in the object. You just replace a string. And you can use the previously shown buffers for that. So what will happen now is at the end of the lifetime of this data structure you created with unserialized, this object will be destroyed. And the destructor will go to the object handler table, which is your stack buffer, and take the second entry, and we'll call it. You see, what we do is we just have an address there that points to exchange EAX ESP in the ret. So after the exchange EAX ESP, the stack pointer will be pointing to the first slot of your buffer. So what you do there is you put something more in there. You want to have a normal return-oriented programming thing here. So what you need to do now is adjust the stack pointer. And you just do that by returning into a pop and ret, which is very easy to find because it's all over the code in PHP. And after that, you will actually return to the code stored in the third slot, to the pointer stored in the third slot. And what we do is we will put in the address of send evil string. And this is just a normal return to libc way to call a function. And the send evil string gets 3 parameters. The first one is the actual PHP code that's supposed to be evaluated. The second one is a null pointer in this case, but because it should be the pointer pointing to the return value, but we don't need the return value, so you put in null. And yeah, the third one must be a pointer to readable memory, and we just put in the same pointer at the the PHP info string. And again, this all is in a region of the stack you completely know everything about. You know the start address and the end address. So you know where the PHP info string is. And this all only because you have put it with the post data pather in the right spot. And the other thing is, null bytes are no problem here because you can also put null bytes in the post request. Yeah, and for completeness, what you would do, put in an empty slot is the send bailout function, so that when you return from the executed PHP code, you would end up in send bailout. Anyway, this will crash because the address, this is in a place where I told you about the jump buff. The jump buff is a try-catch around all the execution of PHP. And when send bailout is called, it will use the jump buff to restore the stack value. And the problem here is that we are in a place of the stack that's already above the jump buff. So the jump buff will not work. What will happen is the PHP code will be executed, and afterward it will crash. You can, of course, make the exploit more complicated to move it back downwards to the stack so that you don't overwrite the jump buff with the PHP code. But this is the easiest way. Your code will be executed, but at the end it will crash. So that was a talk for now, so I will show you this simple demo. Actually, it's not so spectacular because so the first thing I show you is how I create these exploits for property-oriented programming. What I do is I will select the classes I wanted to use. I told you I use a send log. I will create all the properties in the class with the same access restrictions as in the original class, because it must be of the same type, otherwise the unserialized will not override the right property. And then I will fill the constructor with something that fills the properties in a way that the exploit works. In this case, we remember the writers property, it has to be filled with a list of writers. And in this case, I just instant this class, which I defined here, and again I have put in the properties I want to have. In the constructor I create the specific objects or put in the right data, and again this is the send mail class doesn't need to be any property at all in this case because I just want a dummy class, so it's just an empty class. But the pvic view again defines a template in the smarty object. You see I create a smarty object, and in the template I put in the PHP code. And in this case, I was very lazy and put in the global variable PHP code in there. And yeah, the Smarty again will define the properties that are required to hit the code. And in the constructor, I will just create this special resource XPL and set the output filter to an empty array because I don't want an output filter right now. And here I just tell it the callback for the XPL resource is this object, which is pvc smarty, and the eval method. Yeah, and then I can define the PHP code I want. In this case, it's PHP info. And then I initiate the send log, put this all into an array. The first element will be the payload, and the second element will be just any value. I will serialize it, and then there's a little trick. I replace the serialized 999 with a 0. The idea here is I already have the 0, which is on my payload, and if I put another 0 in there, and this will get unserialized, then it will unserialize all the payload. And in the end, it will put in the second element to the array, and the second element will also be key 0, so it will delete the first one. So I can ensure by manipulating the serialized data here that at the end of the unserialized, all the payload is destructed. And this is sometimes required because otherwise you might hit a fatal error or an exception, and this will end up in PHP terminating the request in an unsafe way, and so your destructor will never be called. So you have to ensure that the destructor is called in the end. Yeah, and then because I was very lazy this time, I just create a GET request. I echo it out. The host is t-test system. In this case, it's a cookie pvig auth, which is x equals the base 64 encoded exploit. Yeah, and actually, I patched my pvig. It's the latest version, but I patched it back to not have the blacklist. So all the exploit here will not tell you anything how to bypass the blacklist. You would have to do something to the serialized string after this here. So you have to like 3 or 4 modifications. When you do that, it will still work, but I don't show you. So you shouldn't see that clear. So what I do is I will show you when I just execute the exploit, it will create the header, which is all the serialized data. And yeah, and now I will just use netcat to pipe it to netcat. And you will see, oh, it executed. When you know PHP, you know that this looks very much, where's the mouse? It looks very much like a PHP info. And yeah, it is a PHP info. So we executed PHP info on the target system. And now I will just go back to the source code and change the code that is executed. Yeah. Again, I do the pvig exploit, which will be this time a different string. And now I pipe it again, and you see it executed system comment, uname A, and user bin ID. And by just changing this thing, you can execute anything you want. And of course, sometimes you maybe hit a web server with PHP safe mode and so on, or OpenBasedir. So you would just take the research I presented last year at Blackhat and create an anti-safe mode exploit, anti-OpenBasedir exploit, and just put it in the serialized data. Yeah, this was the return, the property-oriented programming thing. Now the second example, which will be the last one. Yes. It's a little Python script I wrote to exploit the unserialized use of the free bug. If you saw something about my syscan talk, you will see that I already posted something like this. But actually, if you compare it to the syscan talk, you will see that all the second half of the exploit, how to achieve code execution, is completely different from what I presented at syscan. Because people told me I let their brain explode with the other method. So this one was actually far more simple than the previous one. So okay, I execute this, and oh, actually it's really fast this time. When I tried this in my hotel room, it was endlessly slow. I don't know why. Same VMware. So what is happening here, it will first send some serialized data and determine the size of an integer and so on, and what PHP version it is. I didn't show this today because I don't have the time, but if you look at the syscan slides, you can see how this is possible. And then it will leak the address of the object handlers, will leak the object handlers, will optimize it to a better address and scan backward in memory. It will find the ELF header, retrieve all the headers, the program headers, the string table. Then it will look up some symbols, the executor globals, the send eval string. And then it searches the jump off inside the executor globals. It finds a stack address. And now this will take a while. It searches all the code segment for exchange EAX, ESP, followed by return. This takes a while. In my hotel room it took like 2 minutes, but I hope it's faster now. Maybe it will never end. What should happen now is it first searches this gadget, and after that it searches the pop red gadget, which will be done in less than a second. Oh, there it is, and it sent over the actual. It sent over the. Yeah, it searches on the stack for the data the pattern we put in. You see, it found the pattern at some address on the stack, and then it creates a fake object with exactly this address as object handlers, and then it creates the request that uses this object and destroys it. And what it does, it returns into some PHP code that actually spawns a shell on 4444, which is the PHP shell. I just already connected to it here. It's nothing else than just a thing that receives data and evals what you send it and give you back what it does. So you can just put in PHP code, PHP info, and you have PHP info again, or you put in system, you name a, you see it's a Fedora, and the last one, to prove that we are Apache, user bin ID, and you see we are Apache. I hope you can see that from behind. We are Apache, and yeah, that was a demonstration. Finished. Actually, I don't know, any questions?
Does Suhosin protect against any of the stuff you're doing?
What I presented at SysCan would be protected by the Suhosin. This time when I used the object destructor way, this would not be protected, but Suhosin would make leaking the place where you are in memory harder, because right now Suhosin will, I showed you that when you free some memory, the first bytes will be overwritten with the previous block. But with the latest Suhosin version, this is obfuscated, the pointer. So what you would receive would be an obfuscated pointer, and when this is reused as a string, it will be some garbage, because the string will use a real pointer, but it will be obfuscated pointer, so it will crash. Oh, yeah. So yeah. And when you have Suhosin patch, the latest one, it will not work like this. It will be possible somehow to get around this, but yeah. It's a lot harder with Suhosin. Yeah. No more questions? I somehow expected that.